All right, so the last thing, I'm going to skip that above problem because the reason why I'm going to use that space to talk about the area. So the area of an oblique triangle. Again, we have no right triangles. Oblique is just going to be, if I just draw any old non-right triangle in here. And this is how we started before. So just showing these area formulas to work, and even in my area, I need that height because the area of this triangle is given by 1/2 base times the height. And even filling things in this case, the base, that because I drew H where it is, would be C. The base would be where from a vertex to the opposite side. But then H, that's a problem. So if I look at H, I can describe it the same way I did before. Before I said this is a right triangle. If I consider this angle, the sine of A can be written as H, the opposite side length, over B. And if that's true, well, H then is really B times the sine of A. So if I plug that in for H, here is a formula for area that doesn't use the height. It just uses two side lengths and an angle. And why these are specific and why these are important is because for every single one of these cases, we have two sides, so like this first one, BC, and their included angle. If I look on the second one, A and B, and the included angle, the one that's between the two. So as long as I know two sides and the angle that's between the two, then I can find the area of any triangle. So for example, if I've got a triangular lot having two side lengths of 90 and 52, and the included angle is 102 degrees, and I've got a 90 meters and I've got a 52 meter. So if I've got this case, all you need to know is two sides and an included angle. And if you wanted to give these names, we could say A, for angle A, we could call this B, and this is B is 52, and C, just because if you like writing down the formula, BC sine of A, then we can fill those things in. Our area then would be 1/2. We said that B is 52, C is 90, and that's times the sine of 102 degrees, and multiplying that all out. We get 2,288.9 meters squared. Don't forget a label. So this whole section is a lot of calculate. I mean, your calculator's taking the brunt of the work. You just have to know how to use the law of sines and your ambiguous